In this video, I am going to go over 5 questions in the study guide. That's about a third of. We've only got 14 questions in it. And these 5 questions are going to be the ones where students are struggling the most that I've seen. If you have questions that are outside of these 5 questions, then you want to come to the Zoom chat and ask me for help. So you don't have to watch the entire video. It'll be question 2, question 4, question 9, question 12, and question 14. Those are the 5 I'll go through. And just right off the bat, question 14, there's a typo in the answer or in the question. And that's where I think a lot of students are struggling with that one. But I'll get to that when I get there. So just in case you don't need to go through the whole video to figure out what it's about, question 2, 4, 9, 12, and 14. Any of the other questions you want to ask me directly in the Zoom chat. All right, now with that portion done, I am going to share this screen and we are going to go over some test taking strategies and tips that I recommend you all use. I'll tell you all how I think about the questions and just little tips and tricks you can use as we go through. All right. So starting with question 2, here it says, excuse me. And let me zoom in just a wee bit in case you guys can't see. All right. This one says directions are to select the correct values from the drop-down box. All right. And it says, given that the square root of 120 is equal to x square root y. And this is asking us to go ahead and simplify this radical. Once we've simplified the radical, we select what value should go in the x spot and which value should go in the y spot. And so to get started with this, I'm going to go ahead and just start with the prime factorization process. To start that, we draw our line. We draw 1 on this left side, and then our radicand on the right side. That's the number under the radical. That's this number here, the 120. And then we begin the process of using our prime factors to reduce this. The first number I think a lot of students like to try is 2, but this one also has the factors of 5 and 3 available. I usually like to do the largest factor possible, but since this is for you all, I'm going to do it the way I think most students will do it. We'll simplify with 2. How many times does 2 go into 120? It goes in 60 times. What prime number can go into 60? 2. How many times does that go in? It goes in 30 times. What prime number goes into 30? We could use 3, but since we've been using 2 already, let's go ahead and use 2 again. How many times does 2 go into 30? 15 times. What prime number goes into 15? 3 goes into 15. How many times? 5 times. And then 5 goes into 5 1 time. We've started at our 1. That's always our starting point. And then we know we're done when we get to 1 down here. All right. So that's our process for the prime factorization. And I do realize I went through that kind of fast. So if at some point I lost you in that, you may want to come back to the Zoom chat to ask, hey, Mr. Williams, I'm not quite sure about what's going on in the prime factorization. If you need to check these numbers as you're going on, that's what this Desmos is here for. If you need to check to see whether something is a factor of or not, that's what Desmos is there for. Divide whatever you're testing by the prime number. If it gives you a decimal, we can't use it. If it doesn't give you a decimal, then you're good to keep going. All right. My next step in this process is going to be to draw my radical sign with those numbers written out underneath it. So I have my radical, and then I have 1, 2, 2, 2, 3, 5. So 1 times 2 times 2 times 2. 1, 2, 2, 2, and then times 3 times 5. And as you all are writing this out, you're probably doing it on a sheet of paper or on a Kami document. Make sure you're keeping this in check. Make sure you're not forgetting any numbers because this step will really throw you off. Now here is where our index comes in. It's really important that we realize what our index is. If you look in the original problem, there's nothing here. All right, there's nothing there. That's not me drawing a 0. That's just me circling what value is there. And so anytime we don't see something written out, that means our index is going to be 2. Okay. And what this index means is that we are looking for groups of 2. Groupings of 2. Of dos. Groupings of 2. Okay. So when we continue this problem, I'm going to look for groupings of 2 to pull out of my radical. And I see I've got a pair of 2's here. That means these 2 things can go out. I don't write it on this step because sometimes that confuses me. What I always do is just draw my arrow, and then on my next step is when I write it. Let's use blue. All right, in my next step, I write it out. I have my 2 on the outside, and then I still have this 1 on the inside times this 2 times this 3 times this 5, okay? And here's this last step is where I go and I simplify everything. I have 2, square root 1 times 2 is 2, 2 times 3 is 6, and 6 times 5 is 30, all right? So we end up with 2 roots 30. And these are the values that we have for our x and our y. We see in this position, we have an x, which is 2, and then we have a y. Now, here's where I have seen a few students get confused. Our x is not in the place of our index. Our index goes here. It goes, I guess, right in that little V section. I call it the porch, but it goes right in that little V section of the radical sign. This x is next to it. And so that is not our index. Since we have nothing in that spot, our index is 2. And so since I know a lot of students struggle with that, that's just something you want to be mindful of while you're doing this and as you do your test the following day, okay? And so our next step, I've finished that. I'm done annotating. What we see now is we're going to pick our answer choices. We've got 2 in the x spot, which is right here. And then we've got 30 in our y spot. Boom. There we go. That's how we do number 2. Now, our next most missed question was question number, actually, let me clear my annotation first, and then we'll move on to the next one. Our next one was question number 4. Our directions say to select all of the correct answers. Here's one where if you select just one of them or something like that, you will still get credit for selecting the correct one. If you miss one of them, we won't penalize you for that. However, if you select the wrong answer choice, that will hurt you. But this says, which of the following are not in simplest radical form? All right, so that's asking which one of these can we reduce more, or can we bring to a smaller number under that radical? My first thought when I look at these, let's go ahead and pull up my annotation tool. My first thought here when I look at these, as I've just briefly glanced over, I see that 2, that number's prime. We can't reduce 2 at all, so that's going to be in simplest form. There's no way we can simplify that radicand. Same thing with this one here. So I know these 2 things are already in simplest form. My next step is to look at the other 2, and I'll just look at them in the order of the equation. We have 5 cube root of 3. And before I continue with this question, I'd like to use this opportunity to piggyback on what I said for that last question. This 3 right here is our index, okay? Do you see how we have our 5 next to it? And this 3 is kind of sitting in the little V section of our radical sign. Our 5 is on the outside of it, so it's not our index at all. Just wanted to make sure that's clear. Those 2 things are very, very different. We started with the 3 as our index, and if we have to simplify, we'll end with the 3 as our index, okay? That's what those IXLs are there for, to help get you prepared for stuff like this. But now back to this question. To see if this is in radical form, I'm just going to go ahead and do it. This number is pretty small. We're looking for the cube root of 12, so I'll start my prime factorization process. 1 and 12. My number goes into 12. Since so many students like 2, I'll keep going with the 2s. 2 and 6. What goes into 6? 2 and 3. What goes into 3? 3 is prime, so it's just 3 and 1. We start with 1. We end with 1. All right, and then we write these things out under my radical. I keep my 3 as my index. And I have my 5 still out here. I don't write it really much, right? I don't need it right now, but just so you all know it's still there, I'll write it out. We have this 1 times 2 times 2 times 3. And since my index is 3, okay, since my index is 3, that means I'm looking for groupings of 3. Ooh, forgot how to draw H right there for a second. I'm looking for groupings of 3 when I do this. Now, when I look under my radical, I don't have any groupings of 3. And so that means these things just get multiplied back together. And I end up with 5. Cube root of 1 times 2 is 2, times 2 is 4, times 3 is 12. So this is, in fact, in simplest form. So I'm not going to select this one either. Now, it would be really devious of us teachers to make it so none of the answers or options are a possible answer. And so now that we've checked one of these, we know that this is going to be the one that we select. This one is in simplest form, so we're not going to select that one. This one here is in simplest form. We're not going to select that one. And this one here is in simplest form. So we're not going to select that one. And so this is me giving you all test taking tips for this portion here. Since we know that these 3 are in simplest form, this one has to not be in simplest form. All right. This has to be, this one we can simplify it if we choose to. And if you remember, we're trying to figure out which one of these can we simplify. And so without having to work out another one, we know that this one is going to be the cube root of 64. Now, if you want to work it out and you want to see it worked out because you just like to go through the process, you can do that just to check it. And if you want me to work it out with you, you can come back to the Zoom, ask, and I will work with you on this one. Okay, so let me clear these annotations and we'll move on to the next one. If at any point what I'm saying doesn't make sense at all and you're not quite catching it, come back to the Zoom chat, ask me, and I will help you. Or if you have a question on one of these that I'm not going over, then come back and ask me. So number 9 is the next one. Excuse me. Number 9 says to fill in the boxes below. Those are our directions. And we're going to simplify 7 times the square root of 8 plus 2 times the square root of 2. And then this is like number 2, except we're adding these things and then simplifying. So my first step, when we are adding or subtracting radicals, first we need to check what our indices are. Check if they are the same. I don't have anything written here, and I don't have anything written here. So that means we have an index of 2. And that means we can actually do this operation between these two. Or we might be able to do the operation between these two different radicals. The next thing we have to check is if we can simplify them, we need to do that first before we either add or subtract them. And that's the difference between this adding and subtracting and then multiplying. So I see that I have a prime number under this radical. I can't simplify that at all because you can't pull any factors out of a prime number. That's the definition of prime. But this one here, this square root of 8, 7 times the square root of 8, that one we can simplify. All right, so we've got 7 times the square root of 8. My first step, let's draw my line and go ahead and write out 1 and 8. Now we're going to think about what prime numbers go into 8 evenly. 2 does. 2 goes into 8 4 times. What prime number goes into 4? 2 does. Once again, it goes into 4 2 times. And then what prime number goes into 2? 2 does. And it goes into 2 1 time. All right. So we started at 1. We ended at 1. And then what we have next is, I'm going to use a different color for this step here. What we have next is, what color should I use? I'll use blue again. We've got this square root with 7 on the outside of 1 times 2 times 2 times 2. And since our index is 2, remember that, we're looking for groupings of 2. All right, groupings of 2. And so I see I've got 2 2s here. It doesn't matter which two 2s you decide to circle. That's kind of a tongue twister. As long as you circle a pair of them, all right, to pull those out. And these things get pulled out. And here's a question I see some students having is, hey, Mr. Williams, what do you do with that 7 when we pull those 2's out. Now remember, these things are getting multiplied inside, so they need to get multiplied outside as well. So when we rewrite this, we end up with the 7 times the 2, and then we still have our square root of 1 times 2 inside. And then our next step is just go ahead and solve everything that we have written out. 7 times 2 is 14 on the outside, and then on the inside, 1 times 2 is 2. And then finally, we can do the operation. We've got 14 root 2 plus 2 root 2 is equal to, and then we need to figure out what that x and y is going to be. So when we do this, we are going to add our like terms, if you want to think of it that way, our outsides of the radical, and then the insides stay the same. So we're going to add the 2 green pieces, the things that are underlined in green, and then what's underlined in that burgundy color stays the same. 14 plus 2 is 16, and then we keep that square root of 2 the same. And so these things correlate with our x and our y. Our x, instead of it being a drop down like it was for question 2, we just type it in. X is going to be 16 and y is going to be 2. You don't have to worry about typing the square root because y is already under the square root. So you don't have to type it. All right, this one had a bit more steps. So if you got lost at any point along the way, rewind it, watch it again, or come back to the Zoom and I'll help you out, all right? All right, that was question 9. Next, we're going to look at question 12. And this one says, to fill in the box below. All right, so all these ones where you're having to, or I've seen students have the most issues, are ones where it's not a multiple choice question. It's one where you actually have to work out the problem before you can get to your right answer. So when you're doing this, make sure you're really well prepared for that portion of the test, because we're going to have things like this on the test. All right, so this is, for the most part, just like that last one. We need to first simplify both of these before we can move on. And just a little key, one of the things I just noticed here is that instead of having one radical as what it's equal to, we have 2. We start with 2 radicals, we end with 2 radicals. So that means we just have to simplify both of these, and that'll be our answer. If you don't get what I mean, it'll make sense. I'll go ahead and I'll do this one with you, or for you, I should say. All right, so we'll start with this 2 root 40. We always start with our line. This line might be kind of short. And our radicand, that's 14, not 40. I'll get the scale. All right, 40. What prime number goes into 40? Instead of doing 2 this time, I'm going to switch it up a little bit. I'm going to do 5. Now remember, anytime we're working with prime numbers, if one of them ends in a 0, then you can use 2 as your prime number, or you can use 5. From time to time, you will be able to use some of the other ones, but those are always going to be 2 givens anytime you're working with something that ends in a 0. All right, so I'm going to start off with 5. How many times does 5 go into 40? 8. What prime number goes into 8? 2 does. How many times? 4 times. Then we got 2, 2, and 2, 1. Okay. Now we've got our 1 times 5 times 2 times 2 times 2. Don't forget one of those 2's, like I almost just did. And then we're going to go ahead and circle our groupings and move it out. And that's one thing I didn't mention this time around. We have the same index for both of these. The reason why we don't add them up in the end is because they have different radicands, and we can't add up things with different radicands. All right, so since these have an index of 2, we're looking for groupings of 2. I see a pair of 2's. We pull those out, and what we're left with is 1. Let's go ahead and just scribble it out real quick because those come on the outside. We're left with 1 times 5 is 5, times 2 is 10. All right, and we've just figured out this first one is a 2. For the second one, I'll write in purple. Oops, that's black. Second one, we have 5 root. Ooh. we got to pause real quick because I just made a mistake. One that's super easy to make. And I'm actually kind of glad I made it just now so you all can see and hopefully avoid it in the future. I started off with 2 root 40. I pulled my 2 out and I ended with 2 root 10. If I started with 2 on the front and I pulled a 2 out, this shouldn't be just 2. This should be 2 times 2. And instead of having 2 root 10, this should be 4 root 10. Okay, so that's a tricky part that you all need to be careful of. All right, so this should be 4 root 10. And instead of having this as 2 root 10, right in here, it should be 4 root 10. All right, got it? So I made that mistake. It was on accident, honestly, but it turned out to be a great learning experience because this is something that is super easy to get tricked up on. All right, and then we'll move on to this next one. And I'll try to not make the same mistake twice. Okay, all right, so we've got 5 root 320. All right, we start with our 1 and our radicand. Run 1 and 320. Since this ends in 0, we can go with 5 or we can go with 2. I think a lot of students go with 2, and since this number is kind of big, I'll go ahead with you all, show you how it works. 320 divided by 2 is going to give me 160. That divided by 2 gives me 80. 80 divided by 2 gives me 40. 40 divided by 2 gives me 20. 20 divided by 2 gives me 10. 10 divided by 2 gives me 5. And then 5 divided by 2, or we don't divide 5 by 2. That doesn't work. So you also want to make sure you don't get in that pattern of doing the same thing over and over again, because I was really about to do 2 and 1. And that would not be correct because it's not 2 and 1. 5, we can't divide by 2 because it's not going to work because that'll give us a decimal. Instead, we divide by 5 because 5 is prime. 5 and 5 is 1. And here we have it. We started with 1 and we end it with 1. And then here is a really tricky part. I'll show it to you all here. Hopefully it doesn't confuse you all. I've seen some students go ahead and just take their pairs out here. Since we're dealing with the index of 2, I got a pair of 2's here. I got a pair of 2's here. And I got a pair of 2's here. So instead of writing my index or my radical again with everything written out, you know what, never mind. I'm not going to do that because I think that'll be confusing. I'll keep doing it the way I've been doing it. We want to make sure we bring down this 5. Do that first so you don't forget it again. And then we're going to write everything under. 1 times 2 times 2 times 2 times 2. How many 2's we got? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4 times 2 times 2 times 5. All right. You always want to go back and just check. 1, 1, 2, 3, 4, 5, 6. 1, 1, 2, 3, 4, 5, 6, 1. All right, we've got all our 2's written out. And since, like I said, this is an index of 2, we need to pull out groupings of 2 that we see. So we got a pair there, a pair here, and a pair here. We've got 3 separate groupings, so that 2 needs to come out 3 times. There, there, and there. All right. So on the outside, what we have now is 2 times 2 times 2. And then we got to remember to keep that 5 in there. Times 5. And we still have our radical. 1 times 5 under the radical is just going to be 5. And then here's the easy part here. We just go ahead and solve it. 2 times 2 is 4. Times 2 is 8. Times 5 is 40. And we end up with 40 root 5. So I'm going to go ahead and write. This will be 40 in this box, okay? So this one had a little bit more going on with it. I made a couple of mistakes going on that I hope you all can catch as you go through this. You want to make sure you bring down that number outside of the radical along with it, all right? Not the index, because that's very different. You don't bring your index down and do any operations with it. That simply tells you the number of groupings you're looking for. All right, and this last one, question number 14, like I said in the very beginning of the video, this one here I made a typo while making this study guide. This shouldn't be minus 4 cube root of 48. This should be minus 4 cube root of 28. All right. So if you got stuck with this one, change it to, when you're writing it down and working it out, change it to minus 4 times the cube root of, or the square root, I'm sorry, the square root of 28, and then you'll be able to find your answer. All right. I'm going to do one more thing to try to help you all out as you do this. Something that I think will be beneficial to you all. All right. Last thing, this is going to be on question number 1, just because I think it fits really well here, and you can use it on a bunch of the other ones. To make this a little bit quicker as you're going through this test, so you have enough time to do the ones where you can't use this little shortcut, I'm going to kind of show you all a little bit of a cheat way to do it almost. So it's asking us to simplify the square root of 180. To type this into Desmos, I'm going to click the Show Keyboard button, excuse me, and then I'm going to click my square root sign. If you need to type in a cube root, you can click the functions, go to the MISC, miscellaneous, MISC, and then we've got, excuse me again, we've got this one here that has this in where our index usually is. You can click that and you can type in whichever one you need. I only need a square root, so I'm going to type that in. And then we have square root of 180. It gives me this decimal piece here. So what I'm going to do is, instead of going through the process of doing my prime factorization, I am going to type in my answer choices right underneath it and see which ones give me the same decimal. All right, so my first one is 2 root 20. 2 root 20, I'm looking for this decimal, so that doesn't give it to me, so I know that's not going to be the answer. My next one is 5 root 6. I don't get it from that one either. And then the one after that is 6 root 5. Oh, and here I see my 6 root 5 gives me the same decimal that the square root of 180 does. So I'm going to click that. That's going to be my answer. All right. I'm not going to do that for the rest of them because this should be enough to get you going with it. And if you need some more practice with it, let me know, and I can go over it again with you in the Zoom. Okay. So that's going to be it for what I do for the study guide review. If I were to do every question, it'd be super duper long, and no one wants to watch an hour-long video on math stuff like this usually. So I'm going to leave it there. If you have any other questions, you can come back to the Zoom, ask me, and I will work with you as best I can. And then don't forget, we have office hours after school today, or on Thursday. We have school office hours after school, Tuesday, Wednesday, Thursday, 2 to 2:30, and you can stay a little bit longer usually. I don't mind that, working with students. So get working on that study guide. If you need help, let me know.